And we're live. Welcome to another edition. This is number 12 in our series on Roxim software. I'm your host, Tim Van Milligan. Our process here is we're here to provide your answers to the questions that you have. Did I say that right? We're here to provide answers to the questions that you have about how to use Roxim and, rocketry in general. I got a question that somebody's already submitted, which is more of a general question than a specific Roxim question, so we'll answer that. We'll also get into the Roxim software. If you're new to this live training session, we're using the Roxim software, and let me show you my desktop so you can see it here. If you're new to it, to find the Roxim software, you go to apogeerockets.com. And then there's this banner bar here at the top, and it's a carousel, and it just kind of rotates through. And you'll see that there's little arrow buttons right here that you can click on, and it will take you to the next banner. And that's the Roxim banner, and so you go ahead and click on that. And that will take you to a page where you can download the free trial version of Roxim. Our first question, I want to talk about it because I'm getting all these stupid pop-ups. It came through email, so let me bring up my email so I can close it up here real quick. I'm also over here, I'm also monitoring a second monitor where I can see your questions as they come in. We have Chris Britt that says hello, Gregory King, who seems to be a regular here, which is really cool. He says, not about Roxim, but I'm still hunting for a G motor for the Zephyr, if that could be addressed. A G motor for the Zephyr. Okay, so we'll talk about the Zephyr. I might talk about the Zephyr more. I got some ideas for the Zephyr. But the first question comes from Marshall Woodford. He says, I have an overbuilt Lock 4 kit that weighs 1,600 grams empty. It's built for a level 1 attempt. I ran several simulations with Aerotech DMS H100W. So DMS stands for Disposable Motor System. So it's a single-use motor, not a reloadable. And the calculated optimal delay is 7.8 seconds. So I set a custom delay of 8 seconds and reran the flight. In the 2D flight profile, the rocket doesn't reach apogee until 9.89 seconds. And the parachute doesn't show deployed until 10.44 seconds. But my delay is set at 8 seconds. Why is that? Okay, so that's Marshall's question. So he's got a Lock 4 kit, and let me go here. This is the Apogee website. If you go to the search bar right here, you can type in Lock 4, and it kind of shows you a picture of what the Lock 4 looks like. And then if you want to download the Roxim file, just click here on the Roxim file, and it will jump down to the bottom of the page where you can download the Roxim file. So I am bringing up Roxim, and here's Roxim. This is obviously not the Lock 4 rocket kit. So let me go ahead and open that up. While I'm doing that, let's see, Roxim Designs, Lock 4. Okay. While I'm doing that, so it brought up my Lock 4. Let me check the comments here. Joe Noble says, hi, Tim. How you doing, Joe? Hope you're having a great day. If you're watching this live, and right now it says we got 11 people here, go ahead and share this with your friends. Maybe they want to learn a little bit more about rocketry too. But go ahead and also, like Joe did, say hi, Tim. I'd like to know who's in our session. And if you stick around the entire session, and we run about an hour long, we're going to have a little contest, and the prize of the contest is this nice poster of the IBIS. Down over here, This is the one that I'm going to be giving away, but you have to log in first by saying, "Hi, Tim," and then later we'll have a little contest, and then I'll tell you what the rules are. Only one person's going to win. It's a nice, this poster right here. This is, last week I had the Ibis kit sitting here on the desk. This time I have the Sky Torpedo. And I was looking at this poster, and this is a brand new poster, but my artist that made it, he took a photo of the real rocket instead of using a rendering. And the reason I can tell is that there's a ding on the wing, and I can see the ding there and the ding there and the ding there. This is the actual rocket that I actually flew, and I ding them up because I do fly them. Yeah, so it's not photoshopped. Everything else is photoshopped, but not the rocket itself. We probably should have took the dings out. So go ahead and sign in. Al says hi. Love the lessons. Al Anzik is local here to Colorado Springs. It's nice to have a local here. Last week we had somebody from, was it Thailand or South Korea? Oh, and we have Dignant Joshi. He's from India. This is kind of a global session today. Dignant writes, I want to know how to design my rocket glider on Roxim software and to be able to use the simulator. Okay, that's a really good question. That's a big question. Don't know if I'm going to get quite to that one with all the other things that we want to talk about today. Ralph Strasser says hi. Roland Zacher says hi from Ottawa, Canada. I think I called you Ronald last week, Roland. Sorry about that. Somebody made me aware of that. Okay, so getting to the Lock 4 design here on the screen. He was running a, well, first he had a 1,600 gram rocket. Mine weighs 963. So I need to add about 700 grams. So I'm going to do that real quick by going to the mass override. And it's already set for mass override. Let me uncheck it and see what the new mass is. 793. So now I'm 1,000 grams lighter. The other thing I want to check is where the center of gravity is. The center of gravity is at almost 28 inches. So if I'm going to use a new mass override and I make it 1,600 grams, I need to put the center of gravity over here at 28 inches. So watch my CG symbol as I hit the tab key on my keyboard. See it jump back to 28 inches. So now we're at the same situation where Marshall was. So let's load an engine. I am using Roxim version 10.2. The reason I can tell is because we got a new icon for launch preparation. It's basically just, setting the rocket on the pad, and there's two little arrows, a gray one and a red one right there that show the rocket coming down on the launch pad. So I'm going to click on that, and it shows the back end of the rocket, and we're going to load an Aerotech H100. So I'm scrolling through the list to get down to the H100s. So here's the H100W. Click on that. And he said he had set it at 8 seconds. So let's go ahead and set it for 8 seconds. So I'm going to do custom. And I'm just going to type in 8 seconds. And use that. And click OK. Under flight events, the maximum ejection delay. Okay, so that's going to pop out at 8 seconds. Looking over here, we have Brian Barbalis. Hi, Tim. Hi, Brian. Glad you could join us today. Under simulation controls, I leave that alone. Starting state, we got a 48-inch launch rod. Since this is a big rocket, I'm going to change that to a launch rail, which are 98 inches long, which is 8 feet. Launch angle, we're pretty much almost straight up, so I'll make that straight up. Type in a 0 and hit the tab. So now we are dead straight when we're launching it. Launch conditions, I don't know where Marshall was launching his rocket, but my standard Conditions are as a altitude of 700 feet above sea level, which is kind of the Great Plains of the United States, Illinois, Iowa, somewhere in there. Temperature, this is a standard atmospheric day of 59 degrees, so it's a late spring day with an 8-mile-an-hour wind. So let's go ahead and run the simulation by looking at the flight profile. And it brings up our flight profile screen here, and the rocket is right down here, and it's pointing straight up. So I'm going to go ahead and launch this, and the rocket's taking off, and the wind is blowing from the left to the right. So you can see the wind blowing the smoke, but the rocket kind of arced into the wind a little bit, and it popped pretty close to Apogee. So I'm just moving the slider bar down here on the bottom, just kind of seeing where Apogee point is. Boy, that's like really close to Apogee. So one of the questions he asked was the parachute didn't come out to 10 point something seconds. If you look down here on the flight time, he's right, it's 10 point something seconds. And that's because this is not the delay, this is actually the flight time. So the way rocket engines work is the rocket propellant burns, so you have some amount of time for burning the propellant, and then from that point, once the propellant is all burned, then the delay starts burning, and that's what starts the ejection delay clock. So we're starting at that point, and then we're going to count 8 seconds from that point to when the parachute comes out. So we can look at that H100, and we'll go back to that and figure out the exact burn time. But another way to get it is to come back down here, and right when the smoke stops coming out of the rocket, we know that the motor has stopped producing thrust. So we're almost at 2.5 seconds. If I want to get a little bit more accurate, I can click on the Decals button right here. And I can see that our thrust force at this point in time is 0 seconds. So if I move the slider bar ever so slightly, I'm trying to get it to the point where that thrust just stops at 0. Yeah, I'm going the wrong direction. It's really tweaky right there. Somewhere around 2.4 seconds is when the thrust burns out and then the delay starts. So add 8 seconds to 2.4 should be about 10.4 something seconds. So if we go back up to the top, 10.5, you know, rounding it off, yeah, that's pretty close. Okay, so let me cancel out of that and then go back here to the optimal delay, and it says 7.9 seconds, which is pretty close to 8 seconds. And it tells us that the rocket, see the little icon here on the parachute, on this parachute? The icon is pointing, the arrow is pointing downwards. That means the rocket had gone over the top and was coming downwards when the parachute deployed. We were like really close, a tenth of a second off of our optimal delay. Let me run this simulation again. Let me change a couple of things. First, let me go to the mass override, and I'm going to uncheck that and go back to the original mass of the rocket, which was 700 grams, but we have the motor loaded, so that's why we're at, you know, over 1,000 grams here. Because of that weight of the motor. If I pull the motor out, you'd see it go back down. Let's rerun the simulation. So when I run a simulation and I'm looking for optimal delay, I always run it with a really long delay. So when I go to choose the engine, I'll go down here to the available delays. Now the 8 wasn't available originally, but it's available now because we had typed it in. But the available delay was 10 seconds. That's the longest delay that comes with that H100 motor. And if you want longer, you got to use electronics. If you want shorter, that can be accounted for by drilling into the delay with the delay adapter tool from Aerotech. but I'm going to start here at 10 seconds. And I'm not going to change anything else. I'm just going to run the simulation, and we'll see what this one is. Now I'm kind of cheating here. If I move the screen off to the side, I can see my optimal delay column. It's telling me my new optimal delay at this new mass. My mass went down, so with this new mass, the rocket could actually go higher because it's a lighter rocket. It's going to go higher. So now I would need almost 9 seconds for this particular rocket. And if I move the slider bar here just to kind of manually control the flight, there's the delay popping out. You can see it's still over here. The arrow is still pointing down, so that's pretty close. Now, the thing that I wanted to show you is if you choose a shorter delay with no other changes, you're going to get a different number in this optimal delay column. And this often confuses people, which is why I'm bringing it up. So let's go back and run that simulation one more time. And this time I'm going to choose another custom delay, but I'm going to make it really short. So I'll make it 5 seconds. And I'll use that and run the simulation. And this time I'm going to just go right here to the summary screen. Okay, so we chose a 5-second delay, and now our optimal delay is 5.6 seconds. Nothing changed in the rocket. The weight didn't change, the launch conditions didn't change. So why did this optimal delay change? And for a lot of people, this is really confusing, but basically the rocket, let me show you. So let me go back here to the flight profile screen, and it reruns the simulation when you click on that button. So now let's run the simulation. The rocket takes off. It's going up. It's going up. It's going up. Oh, wait a minute. It's upside down, and the parachute's out. So what happened was the rocket took off. It's going up at 5-second delay, well, actually like about 7 seconds from liftoff, but 5 seconds in the delay. The nose cone pops off, and it pulls the parachute out. So the parachute deploys, but the rocket still has momentum going upwards. And you can see right here on the screen, it's dragging the parachute up. Instead of coming down, it's dragging it upwards. And there's still some momentum going upwards that it has to bleed off to get to its apogee point. So what it's saying to us is there's just so much momentum going upward, and it's pulling the parachute up. So it's a different configuration. So to find the real optimum mass, you have to run the simulation so that it's going over the top. See, now if I go back here to this screen right here, if I look at the parachute here, if the arrow is pointing up, I can almost guarantee you that optimal delay number here in this column is not correct. It's because the parachute came out too early. It didn't have a chance to hit its apogee point first, which is the definition of the optimal delay. The optimal delay definition is opening right at apogee. So that's why that number is off. So to actually get the right number, you have to run the simulation so the rocket comes over the top, and now it would be the exact 8.95 seconds. So if I go here to the delay again, and I type in 8.9 seconds and hit tab. Oops, I didn't take. Go to custom. I can type it in here, 8.9 seconds. Hit tab and use that value. So now it threw it in here. So yeah, I'm just, oops, it should be matching this number right here. So it should be 8.95. Use that value. And now we do the flight profile. It should be popping right at apogee at the highest point in the flight. So I'm just going to move the slider bar. Whoa. Something went wrong there. This is the end of the thrust, and right there as the parachute came out. So what happened there? Ooh, it reverted back to a 0. .95 seconds. Hit tab. Oh, see, when I moved over to there, this one's a little flaky. I want to use that number. Huh. Something's going on here. I think it's trying to find like a whole number. Maybe let's see if I can make it 9 seconds. I had 9 seconds before, so. Okay. Yeah, it'll work now. Flight profile. Okay, rocket's taking off. Goes up, and yeah, you can see it's like popping out right at Apogee. I'll have to look into why that wasn't working there. I'll have to ask our programmer. Okay, I'm checking my comments over here. Chris Britt asks, did the 10.2 update fix the meter feet issue in motor configuration screen? And the answer is yes. So what he's asking is, say this is a dual deployment rocket. Let's add another parachute here. Let's add a streamer. It doesn't matter which one. I just added a streamer, just move it here towards the middle of the rocket. Click OK, so there's my new streamer. So under flight events, I now have two recovery devices. I have the parachute and the streamer. So the streamer I'm going to deploy at Apogee, and the parachute I'm going to deploy at an altitude, and let's make it 300 feet. So what the question was, prior to version 10.2, if it was assuming this was 300 meters, not 300 feet. So at 300 meters, that's over 900 feet. So I should see my parachute pop out at if I look down here, when I get it down to 300 feet, that's when the parachute should pop out. So it's coming down on the streamer. And that's now the parachute popped out, and I'm just under under 300 feet. So the question, Chris, is yes, it did fix that issue. L. Anzik asked, do the delays on center burning motors begin at ignition, unlike black powder motors, which have to burn the delay material? And the answer on that, so Al is asking, center burning motors, if you look at some motors, if particularly reloads, if you look at the grains, those start the delay burning right away. And so he's asking does that number start from ignition or from burnout of the propellant? And the answer is always from the burnout of the propellant. So the way the motor manufacturers account for this is they put in extra material that burns with the delay to account for it starting burning actually right at ignition. We have a little animation of this on our website. So if you go to our website, Al, you go to How-To and Guides, How-To Technical Resources, and then go to How Composite Engines Work, and it will bring up this screen right here. So this is kind of a center burning motor. So you have a core that runs through the motor, and then here's the delay up here. And when you run this simulation, so the igniter goes in, and then it starts burning, and you can see the delay right here at the front is also burning while the propellant is burning here. And if you watch it burn, you can see it burned. And you can see that the delay, if I do the back button, the delay actually shrunk. So the delay got shorter as the propellant was burning. So let me back that up so you can see that again. You can see that delay is burning off. And see, at this point, right here, is when we actually start the clock. So from here on, so if it was a 10-second delay, from this point to when the ejection charge goes off would be 10 seconds. But in this one, in this simulation, it'll be a little bit shorter because we didn't want to make you wait for 10 seconds. So here's the delay making it smoke, and now the delay is burned out. And then when I hit the button again, the ejection charge will fire. Boom, like that. So this is playing it in real time. Boom. Okay, so hopefully that answers your question, Al. Do you use this program just for seeing what the rocket is going to do, or can you use the program to design your own rocket? I'm guessing both, and that was from Bob Urich. And the answer to that, Bob, is yes. Roxim is a design and simulation program. Where we can design the rocket, like I can go in here to the components. So here's my rocket down here, and I can start adjusting things. So I edited the nose cone right here, and I can take like the length of the nose cone, which is from the tip to here, and I got slider bars where I can make, oops, wrong one. That was 4 inches in diameter. The length. See, I can change the length. I can make the nose cone really long. And now we have a different looking rocket. And then Bob, to answer your question, I can look at this in 3 dimensions. My cursor is really big right here because I made it really big so that you can see where my cursor is moving around on the screen. On your screen, it's not going to be this big. It just looks really funny to me when I see this big cursor. So yes, you can design your own rockets, and that was the question that we got from Dignet. He wants to design a glider. Chris Britt says both, Bob. So Chris answered Bob's questions. Thanks, Chris. Ralph Strasser says, Tim, as a future subject, is there a way to add eBay door like you use on the Terrier Sandhawk? Ralph, as a future subject, maybe. As a current subject, no. Because Roxim is not a Cad software technically. It's a design and simulation. So if you want to use a Cad software, the software that I use is called Fusion 360. And this is from Autodesk. Fusion 360 is it is a full CAD software where I can go in and make the pod doors like that. But this doesn't simulate the rocket. So but I can't export this into Roxim because Roxim doesn't use the same CAD basis that something like this uses. In the future, maybe, but not in the near-term future. So the next year, maybe 2 years, it's not going to happen. I can just almost guarantee that. It's just too hard to do. Lots of good questions. Brian Barbalis asks again, mass override? What's mass override? Mass override it's this screen right here. Is this, you built your rocket. So now you have a built rocket, and then you have what's inside the software. And you weigh this on a scale, and the weight is different here in real life than what's in your computer. So say this one was lighter than the one that's in the computer. So mass override gives us a quick way to adjust what's in the computer to match what's in real life so that our simulations would be as close to real life as possible. So mass override, there's this tab, and and I use this tab a lot. You can also go, each component in the rocket also has its own mass override tab. Excuse me, I'm talking too much here. Each component in the rocket has its own mass override tab that I could also adjust. So on this one, it says use the values below for all the simulations. So I'd have to check that box. And this forces Roxim, instead of using what it calculated as the mass of the rocket, it's going to force it to use the user input as the mass. If I go to the design components, like if I go to the nose cone, you can see there's a mass override tab here. So if I weigh just the nose cone by itself, I can adjust the weight and the position of the center of gravity so that it matches real life. Excuse me. Ideally, you would like to have everything match. Now, you can also match the mass by changing the parameters of the parts. So I can adjust, like on the nose cone, if I knew it weighed a certain amount, I could adjust the wall thickness so it matches the actual mass of the nose cone. You can also adjust the material, because the material, the density is going to affect also the mass of the part. So there's a lot of different ways to adjust the mass of the rocket. But for me, the simplest and the fastest way is just to do it right here. The disadvantage of adjusting it right here is it changes the moment of inertia of the rocket. And that's going to affect how it reacts to wind. I talked about this in episode 11, which was last week. If you want to see those old episodes, if you're new to this, just go back to the Apogee website. Go to How To and Guides, this tab right here on the top. Go to Software, and then it'll bring up this menu and it says Roxim Live Training. And if you scroll down on this page, you'll see episode 11. And this is where I talked about the moment of inertia of the rocket. It's under why do rockets wiggle when they take off, and it's because the location of the mass of the rocket. The downside of using the mass override here is it's assuming all the weight of the rocket is right here at that center of gravity point. Where in real life you have mass up here on the front, you have mass of the motor. It all balances right there, but by spreading it out, it changes the moment of inertia, so how it reacts to forces. So things with high moment of inertia take a lot of effort to move. You know, this is Newton's first law of motion, is basically the law of inertia, because an object in motion or at rest is going to stay that way unless hit upon by a force. But sometimes that force, just to get it moving, to overcome inertia, you got to give it a little extra push. But once it's moving, it doesn't take much to keep it moving. So that's the downside of using this right here. So if you want the most accurate simulations, you want all your component pieces to have correct weights and in the correct location. So if I would adjust the mass override of the nose cone, I want to make sure that its center of gravity is where it balances. So I would make sure that it balances like right here, and then I'd measure that from the tip of the nose cone for that part. And every part you'd have to measure its own center of gravity and its mass and put those into the software. Whew. So hopefully that answers your question, Brian. Joe Noble asks, why does the Estes Big Bertha model that comes with Roxim say your current design contains no body tubes? That's a good question, Joe. That means there's something wrong with that particular design. Maybe I'll take a look at that. David Moore asks, I wish the shipping would work as good as Roxim with UPS and FedEx. I think he's making a joke there. So Roxim is very dependable, unlike USPS and FedEx. Al Anzik says, thanks, that clarifies it for me. Joe Noble says, it looks like there's a booster and sustainer. With the booster, it has nothing in it. So he's answering his own question about the Roxim Big Bertha. Brian Barbalis says, can you take an Estes Alpha and increase it by 300% and build a Super Alpha? Do we have an increase by X% tool? That's a good question. I can answer that one. Oh man, there's a lot of comments this time around. Don Thomas asks, a larger rocket size over 70 inches tall, can you use just a nose cone blow single deploy on a 54 millimeter rocket for L2 certification? So he's asking about, if you have a big rocket like the one you see on the screen, can you use just single deployment instead of dual deployment for your L2 certification? And the answer to that one is yes, and I highly recommend it, Don. Adding dual deploy adds extra complexity to the launch, and whenever you add more complexity, you add chances of more failure modes. So, the rocket could take off fine, but the dual deployment part could not work, and then you fail your L2 certification. So I am of the philosophy of keep it simple. Just use single deployment. So just one parachute deployed using engine ejection delay is the simplest way. It pops out wherever it pops out, and the rocket comes down. Even though if it may come over the top and deploy too late or too early, as long as the rocket comes back and you can fly it again without any modification, you would pass your certification test, assuming it came down safe. So if the rocket deployed the parachute and it came down and safe and there was no damage to the rocket, so you could fly it again, you could have cosmetic damage, like, you could crunch the end of the fin, but that really doesn't affect if it could fly again. So the answer there, Don, is yes, do that. I highly recommend it. Jeff Miracle, hi Jeff. He asks, do you use the texture button on the individual components, and what files does this use? How do I develop those files? Oh, so he's getting into textures. Textures are like decals on the rocket. Oh, man, we got a lot of questions here. Some of these are going to take longer to answer than others. Ralph Strasser is answering Don. He says, Don, yes, but depending on the chute and the wind, be prepared for a walk. Walking is good. We all need to walk more. It's good exercise. So again, I say yes. Go for just single deployment on your high power level 1 and level 2 certification. You're going to walk a little bit further, but the complexity is less, and you're going to have greater chances of passing the first time around. Dignit says, I always use Roxim to design our model rocket because in India we don't have model rocket kit available. Well, cool. That's great. Don Thomas says, thanks, Tim. Joe Noble says, how do I get rid of the sustainer and just have the booster in the Big Bertha model? Let's see what Joe is talking about. So let's go here to see if we can find the Big Bertha model that he is talking about. Let me make sure that I'm opening the same one that he is. So I'm going to the Designs folder, I'm going down to the Estes folder, and there's the Big Bertha rocket. I'm going to open that. I'm not going to save the changes on this one. So say no. Okay, so he's saying there's a booster on this one. So in 3D it doesn't show a booster, but let's look at the components. So we have a sustainer, and there is a booster right there. Look at that. And there's nothing in the booster. So Joe's question is, so when he's running the simulation he's probably getting an error. In order to run the simulation, at least one body tube in each rocket stage needs to be designated as a motor tube. So we have a booster, but we don't have a tube in there to designate that as a motor tube. So for that, the easiest thing is to get rid of the booster stage. So how do you do that? But he's asking, how do you get rid of the sustainer and just have the booster? Well, we always need a sustainer because the sustainer is the last piece into the air. And if there's only one piece, that is the last piece. So that is your sustainer. But to get rid of the booster, you go here to the Rocket Design Attributes tab. Now this button, we've talked about it before. Sometimes if you hover over it and click on it, it doesn't click. But you have to find the sweet spot, and the sweet spot is in the word attributes. So if I go over the attributes, you see the button, it's changing color just slightly. That means I'm hitting the sweet spot. That's the hot spot of the button, and now I can click on it. So now I'm on the Rocket Design Attributes tab, and I want to go to number of stages, and I'm going to take it and go from a 2-stage rocket to a single-stage rocket. And now if I go to Design Components, and so now the booster is gone. So now only the components are in the upper stage, which is called the sustainer. All right. So, man, we got a lot of questions. On a single stage deployment L2, would you recommend a vent hole or shear pins? And the answer is I would recommend the vent hole, yes. Anything like 3 inches in diameter on your rocket or larger, I would say put a vent hole in it. And then shear pins are extra measure of safety. But if you're going for a dual deployment, I would say don't use the shear pins. Not dual deployment, a level 2 certification. So if you're going for a level 2 certification, I would say hold off on the shear pins until after you get your level 2. Again, you're adding complexity to it, and we want to keep things simple. But a vent hole would work, yes. So a vent hole is, you have air inside your rocket. It's capped off here from the motor, and it's capped off here from the tube. So you have a pressure vessel here. And so at ground level, the pressure inside is equal to the air pressure outside the rocket. But as you go up into the air, the atmospheric pressure is decreasing. So it's getting less pressure on the outside, but the internal pressure remained the same because it's capped off. And so you have a greater pressure. It's trying to push the nose off now because now you have a difference in PSI. So, if the difference is 1 PSI, you have 1 pound of force per every square inch on the base of the nose cone, trying to push the nose cone off. So this is a 2.6 inch diameter nose cone. So I'd have to find the area of the base of the nose cone. So to do that, it is pi fourths times the diameter squared will give you the area. And then you multiply that times the amount of pressure difference. So if I said it was 1 PSI difference between the inside and the outside, you multiply that times that, and that gives you the amount of push acting on trying to push the nose cone out of the tube. So it's kind of like you put a weight on it. And can the rocket, if there's a weight on it, hold the friction around the tube, hold the nose cone on? But if we put a vent hole inside the tube, it vents that internal pressure out. So now there's no difference between the internal and the external pressure. And so there's nothing trying to push the tube off as it goes higher. And it's also dependent on the speed of the rocket. So rockets that take off faster seem to want to push the nose cone off easier than a slow rocket. But again, that vent hole will try to stabilize things, so you don't need shear pins holding it on. But after you get your level 2 certification, yeah, then use shear pins. A lot of people do recommend them. So yeah, go for it. Because you're basically, if without shear pins, you're depending on the friction of the nose cone sliding into the tube to hold it on. And if you don't want to depend on that, and it's hard to measure, so you use a shear pin, and then you know that at a certain force, those shear pins are going to break, allowing the nose cone to come off. Okay. Whew. Chris Britt writes, we're making Tim work this morning. Yeah, you are. I'm getting thirsty again. I'm getting hot. Got the lights burning on me. And okay, let's see if we can, there's some unanswered questions here. One of them was about textures from Jeff Miracle, and then Dignit from India writes, how do you design a glider? Whew. The glider one's a really hard one. It's a long answer, Dignit. So I'm going to pause on that one and go to Jeff's question first. He's asking about textures. So a texture is like a decal. Let me open up the Sky Torpedo, because I think this one actually has some textures in it, in the design file itself. So the Sky Torpedo is in the Dynastar folder. No, it doesn't. I can tell it doesn't, because if it did, there would be extra image files associated in this folder itself. And there's no image files in that folder. So let me see if I can find a rocket to show you where there is textures or decals. And so just by looking in this folder, the Apogee components folder, I can see the Diamondback has a folder and the Avion has a folder. So let's go to the Diamondback, open this up, and you'll notice we have the rocket design, and then we have 3 PNG files. So PNG is a graphics file like a JPEG or a GIF, and Roxim can read PNGs, JPEGs, and GIFs as decal files. So if I open up the Diamondback, and I'll just drop it here onto Roxim. Come on, you gonna open for me? No. Oh, because I'm already in the open. It's the second time I did that today. Okay, so here is the Diamondback rocket, and if I zoom in on it, you can see I have extra decals on the rocket, and these are called texture files. And there's a texture file on the fins as well. If I don't answer this question totally, Jeff, I'll show you where you can get additional information. If I go to the Apogee website, if I go to How-To and Guides and to the Peak of Flight newsletter, and then over here to All Newsletters, and so this gives me all 500, at this point in time, 544 newsletters. And then if on my keyboard, don't use the search feature right here, because they'll search the entire website. I just want to search on this specific page. To do that on your computer, you use, on Windows, it's Control F. On Macintosh, it's Command F. And I'll do that on my keyboard. And you can see it brings up a search bar up here. And now I'll type in a word. Let's type in decal. And it shows me there's 12 words on the page that are decal. And then I'm going to scroll through them and see if I can find the one that I'm looking for. And here it is right here, how to add, it's newsletter issue number 123, how to add decals and decorations to your Roxim designs. So if I click on that, it's a PDF. And you can see, let me make this smaller. And you can download this. You know, if you hover down here near the bottom, you'll get the little icons, so you can download it. We allow decals in Roxim version 7. And the process is pretty much the same as this newsletter. The screens are going to look a little different because we've updated the screens, but all the information is there. So, so down here at the bottom are some examples of decal files. Let me zoom in here, and I'm going to grab one of them, and I'm going to try to use this as a decal file. So I'm going to take a screenshot. Now on the Macintosh, this is easy to do. On Windows, it's much harder. You can get other software to make screenshots easier, but on the Macintosh, it's Shift, Command, and 4. You can see it changed my icon to this kind of crosshairs, and I'm going to draw a line around this box right here. So I'm going to make a image of just that, and it took a screenshot and it placed it on my desktop. So I got to find my desktop underneath all this stuff. And let me just open up my desktop. So right here it says screenshot, and if I open this up, there's my decal that I want to place on this rocket. So first, I want to put this decal file, I'm going to change the name first. So I'm going to call this Apogee Decal. And I'm going to drag that, and I need to put it into the same folder that the Roxim design is stored, because that's the easiest place. Because if Roxim loses the location of that decal, it will always look first in the folder where the Roxim file itself is stored. So on my machine, it was in my applications folder. Come on, open up. And then it was in the Roxim 10.2 build 37 in designs, and then under Apogee components, and then the Diamondback. So I just dropped it into this folder here. So here's my new decal. Here's the Diamondback rocket that I have over here on this screen down here. So now I'm going to change the tube with this new decal. So I'll go to the front body tube because that's where the decal is located. I'm going to hit edit that, double click on it. And I have 3D view shown. You won't see it in the 2D view. It's got to be in the 3D view. Okay, I'm just zooming in so I can see it. And then you go to the texture tab over here. And then you're going to search for a file to use as your decal. So right now the current one is tube decal, but I'm going to change it to the Apogee decal. So I'm going to choose file. Now I got to navigate back to that folder. On the Macintosh, it's pretty easy because it remembers the last folders that I visited. So here's the Apogee Diamondback. Okay, so now I'm looking for that decal file, and I'll just select it and click open. And you can see that it put it here on my rocket. Although, if you look at it real close, let me move it around here a little bit so we can see it. Let's see if I can make this screen a little bit bigger. It distorted the image. All right. And the reason for that is that it's trying to take that one decal file and then just wrap it around the tube like that. Now there is some control that we have on placement, and that's right here. And usually I'll go through these little boxes first and just click on them and see what happens. So I'm going to click on rotate around the R axis. And doing that, nothing happened. So I'll uncheck that. Let's rotate around the S axis. Nothing happened there. Repeat pattern. Let's click on that one. Nothing happened there. Don't be afraid to click on things. Okay, clicking on prevent seams did something. So I need to rotate it around. Okay, so if we look at that original decal file, let me go back here. Okay, so we have red down here, blue at the top, and normally we'd like, the blue at the top and the red down at the bottom. So now it's a matter of orienting it properly so we get that red at the bottom. So now I got red at the side instead of red at the bottom. So let's uncheck that box. And it's still red at the side. So it's a pattern here. So usually that will do something. Okay, so at this point, now we got to actually go and edit the decal itself. So let me go back to this decal file. So this is the hard part about placing decals. Okay, so now on this decal, I got to rotate it. So right now it's horizontal. I need to rotate it vertical. And let's see, on this program is preview. I don't know if this is going to change things. So by rotating it there, I got blue at the bottom, but I want blue at the top, so I'm going to rotate it one more time. And now I'm going to hit save, and it resaved the decal. I don't know if this is going to change it or not, because I don't know how preview works, if it's actually rotating it, or if it's just doing it as the file in preview by itself. Normally I would use a program like Adobe Photoshop. I think there's a Windows version, a free software called GIMP, which is a Photoshop-like program, but it's free if you're interested in that. Let's see, let's go back to choose file. Let's choose a different one. And now I'm going to go back to it, and this kind of refreshes things. Let's see if things changed. Yes, hey, that worked. Look at that. So now I got blue at the top, red at the bottom. But the general gist of this process is, once you have your decal file, you have to orient it the proper way and then place it on the rocket. And then there is some adjustments right here. And these numbers are explained in this article right here. Let me zoom out. Again, this is newsletter issue number 123 that talks about decal placement. The cool thing about decals is once you have them on, your rocket looks a lot nicer. So. And for the future, Roxim Pro with the three-dimensional launch visualizer will show these same decals. They'll bring them right in, which is really cool. So you can decorate your rocket, make it look like the real thing. And that's the purpose of textures. It's just, unfortunately, they're hard to work with. 99% of all people don't use textures. It's us crazy people that are really into Roxim that use it. So we're closing in here on at the top of the hour. So we need to give away this poster. So to be in the drawing for the free poster, you have to say, "Hi Tim," one more time, and it's going to be the not the first person this time, let's make it the third person. So the third one that shows up on my news feed right here on Facebook is going to get this poster for free, just as our way of trying to encourage people to come and watch these Facebook Lives. And now I'm scrolling down to the bottom and seeing if anybody has taken me up on the offer of the free poster. If you do happen to win the free poster, please shoot us an email through our contact form so that we have your address, so we have the proper address. And if you're a customer of ours, that's even better, because then we can actually confirm. So Jeff Miracle was the first. He says, hi, one more time. Don Thomas was number 2. And Chris Britt is the winner of the poster. So thank you, Chris, for playing. We also had submissions from Mark Goulet, Bob Urich, Ralph Strasser, Mark again, Al Anzik. So thank you, everybody, for playing. Thank you for watching. Thank you for all the good questions. Mark, I can't pronounce your name, Mark. Why doesn't Apogee have level 3 kits for purchase? Thanks. The reason is on level 3 rockets, if you are using it for a level 3 certification, number one, it's against the rules of level 3 certification. Level 3 says you have to design your own rocket to be level 3 certified. So that's why there are no kits that are level 3 certification kits, because it would violate that law or that rule and both NAR and Tripoli have that rule that you have to design your own kits or your own rocket when you're doing a level 3. Because in level 3, that's the highest certification level. We need to make sure that you know about rocketry. This is like, you're building big rockets, you better know what's going on with rocketry in general. And if you can't design your own kit, you're not ready for level 3 rockets because there's just so much involved. And that's why it's imperative that you design your own rocket. And also in level 3, now you are specifically required to use dual deployment because you need to know how to use electronics. So there is a process for going through level 3 certification. Again, it's all about safety, making sure that you're safe when you're flying rockets, so that spectators and other people in the area where the rocket comes down are protected as well. These are big, heavy rockets, and they can do a lot of damage, and we want to make sure that everybody's safe. And so I totally agree with both the NAR and Tripoli on this. Is no kits are allowed, and you have to do dual deployment. So that answers almost all the questions. I'm going to try to get to the glider question next time in episode number 13, how to design a glider in Roxim. That is a pretty involved question. It's not a simple question to answer. And it's kind of cheating because Roxim doesn't allow things to glide. So it's just the upward trajectory of the glider that it can do. It can't do once it starts transitioning into glide. It can't do because it can't do it. It doesn't have the equations in it. And I'm trying to think, does the new Roxim Pro have it? And the answer is maybe. I haven't played with it yet, so we'll find out. Any last minute things? So again, thank you for everybody. Don or Joe Noble says, don't know if it's my screen or what, but the presentation appears to be out of focus. It's probably the bandwidth on your internet connection, Joe. So we will post this video onto YouTube, hopefully by the end of the day, so that you can rewatch it if you want, and hopefully it will be a little better quality. So I have got to find the end the stream, and Facebook doesn't make it easy for me. So I'm going to hit the end live video button now, and hopefully in 5, 4, 3, 2, 1, go out and launch.